Welcome, everybody. My name is Stephen Feuerstein. I'm a developer advocate for PL SQL at Oracle Corporation, also lead a team of developer advocates, including Chris Saxon and Connor McDonald. Chris, I think, will probably be joining us today, even though I'm going to be doing all the hard lifting. And so what we're going to do is cover methods and object types and the different kinds of methods are and how you can use them. Before we get started with that, we're running a Zoom webinar, so you can enter text into the chat. But if you have a question, go to the Q&A, click on Q&A, ask your question there. I'll probably answer them in a mix of as I'm presenting and at the end of the session. I also encourage you to provide your own experiences, chat or Q&A, about working with object types and specifically their methods. Let's see, we'll record the session. I'll be uploading the video and the slide deck after we're done, so you can always come back to the AskTOM Office Hours PL SQL page, which I'll show you in just a moment. So let's go ahead and share my screen and show you some PowerPoint loveliness. So we're going to talk about the methods to object type madness. And there's the contact information for Chris and myself. Should be no problem getting in touch with us online. And in addition to what you're going to learn today, we encourage you to take advantage of our 3 main community sites. Of course, there are many other sources of information on the internet for Oracle Database, SQL, PL SQL. But I got to say, I think these are 3 of the best. Oracle AskTOM, which features, of course, one of the best Q&A sites in the planet, in the universe for Oracle Database, plus the Office Hours program, which you're experiencing right now. The Oracle Dev Gym, which offers you free 24/7 access to quizzes, workouts, and classes for what we like to think of as an active learning experience. Don't just watch a presentation, don't just watch a video, don't just read an article. Do all of that, and then take quizzes to reinforce that knowledge and play our weekly quizzes. And you might even play ranked and compete for annual honors at our championship. And finally, Oracle Live SQL. So 24/7 access to the latest and greatest Oracle database. Not only do you have the ability to play around with SQL and PL SQL in that context, but we have an enormous code library of hundreds and hundreds of scripts that you can use to learn more about the technology. And I'll be using those scripts and referencing them in my presentation today. Okay. So we're going to talk about working with object type methods. So object types is part of the object relational model of Oracle Database, which was introduced in Oracle 8 and then extended across multiple versions, of course. And methods are a part of the object type paradigm. So we're going to do a quick overview of object types, then we'll just dive right into all the different methods that are out there. No need to go through the list because you're about to see it all in great detail. So first of all, about object types generally. PL SQL is a procedural language. So in general, you would build most PL SQL-based applications using PL SQL packages, some schema-level stored procedures and functions, but almost completely in packages. Of course, there's an interest in object-oriented development as well, both inside the Oracle database community and outside. And there was a big push many, many years ago to extend relational to also incorporate object features. So that was done in Oracle 8. And that's when object types were added. So object types are Oracle Database's versions of classes. It's not a true object-oriented complete implementation, but at this point, with all the enhancements up through 11G and 12C, the implementation is pretty good. And I've talked to people who have done full object-oriented development using object types, but it's certainly the rarity. However, having said that, you're going to run into them, if only because Oracle uses them for many different features of its own database, including spatial, XML, and more. So you should be conversant with how they work, the syntax behind them. And of course, then you can start building your own. So we support pretty much the broad range of core principles of object orientation, including substitutability, inheritance, dynamic polymorphism, and more. I'm not going to cover all of those today, though I'll touch on most of them in the process of talking about methods. If you'd like to explore the topic in more detail, I set up a little bit.ly, so bit.ly/ORA-OT, that'll take you right to the latest documentation on object types, and there's an enormous amount to consider there. Now, if you look at the code off to the right on the screen, you'll see that I've created this type called food, and it's an object, so it's an object type. It's got 3 attributes. So instead of columns, you talk about attributes for your object type. Name, food group, and grown in. And it also says not final. That's because I'm going to build a subtype off of the supertype, or in this case, the root type, called dessert. And dessert can contain chocolate. We can keep track of the years it's created. So just to cover a couple of simple topics here. Whenever you hear about substitutability in object types, in object orientation, here's the best way to think about it. Every dessert is a food, but not every food is a dessert. So everywhere I have food, I can use a dessert type because it's a type of food. But since not every food is a dessert, whenever I need to use a dessert, I may not be able to use any type of food. So that's the rough cut at substitutability. Inheritance, you'll see in just a moment. So let's cruise on. So about object type methods. So in a way, they're very similar to things you've worked with in packages, procedures, and functions, but they're not the same thing as subprograms in packages or schema level programs. They are procedures and functions, but the way you use them is often quite different. Now you invoke them using pretty much the standard dot notation, but what might be to the left of the dot could surprise you in some cases. And as you see in my little code example here, we've got attributes in my food type now, which you saw before, but I've also added a couple of methods. And you can see the two different types, two of several types we're going to talk about today, the static function and the member function. So there are static methods, member methods. You're about to understand the difference between those two. But first, a quiz, a method trivia quiz. Time to show your age, I mean your wisdom. So as I mentioned before, the object type structures in the object relational model was added, or the extension to relational to object to include objects was first done in 8.0. So here's my question for you. In which version of Oracle database were methods first available for use in PL SQL? And why don't you go ahead and raise your hand? You should be able to click on your hand at the bottom of the screen if you think it was 8, and don't raise your hand if you think it was 9, if you think it was 7.3. I don't know if this is going to work, but we'll see. We got a bunch of hands coming up. 8 sounds like it's so sensible, right? How could it not be 8? It should be 8, but it's not 8. It's PL SQL Oracle Database 7.3. So, and I really mean this as trivia, but why not? So there's a package owned by Sys called plitbulm. I actually don't know what it means. And it's a package that implements the first methods that were ever available in the Oracle database, and it was before the object relational model. And those are the methods for collections. So you can see right in here, you've got all these different functions: count, first, last, exists. I'm sure this is all familiar to you. It's got a bunch of pragmas in it as well. And if we go ahead and switch over to Live SQL. So if you, in Live SQL, search for collection methods, you'll find the script. So here I'm declaring the type, and I'm setting up a variable at the global level just to make things easy, so I don't have to declare it over and over again. Fill it up with the names of my immediate family. So here's an example of calling a method instead of calling a procedure. I don't pass this as a parameter. I attach the method to it and then execute it. So this is the first introduction of object-oriented syntax way back in Oracle 7.3. Apologies. Alrighty, back to PowerPoint. So before we dive into methods, I want to talk about type hierarchies, which I referenced earlier, but it's a very important concept in terms of object orientation and also extremely critical when you talk about methods. So one of the biggest advantages of an object-oriented approach compared to, say, a relational/procedural approach is that I can create these hierarchies of types. So you can see the hierarchy here. I have foods, that's a generic type. Then I have desserts under food, so create type under food. And this says that every dessert is a type of food. Obviously, every cake is a type of dessert, is a type of food. But the really cool thing about object types is that every subtype inherits from the supertype or the parent type. So dessert T is a type that only has 2 attributes defined in it, but it has a total of 5 attributes. It has name, food group, grown in, plus contains chocolate, and years created. And not final indicates that I want to continue with the subtypes. If I say final or don't include not final, then I can't create subtypes off of it. So we inherit attributes from the parents, but we also inherit the methods. So if I create a procedure or a function for the food type, Anything that's declared as a dessert, as a cake, as a whatever subtype of food inherits those methods as well. But we can also override the methods to create our own versions in those subtypes. We'll come back to the object type hierarchies. I've got references in here to the text you can use to search in Live SQL to find the script you're interested in. We'll come back to this in a moment. But that's the basic idea behind the hierarchy, is inheritance from the parent. All right, now let's start exploring the different types of methods that we might find. The first is a static method. Now, a static method is associated with or attached to the type itself. So we use the static keyword, and it returns some information. And the key thing, what static means, is that it's not associated with any specific instance of the type, a variable based on that type. It doesn't change based on what that variable has in it. It simply reflects the type itself. And in general, you'd use this for type level formulas, constants. Maybe I want to track the version number, as you see here. One interesting aspect of attributes inside an object type is that you can't have constants. They're all variables, and none of them are private. They all are exposed in the specification of the type. So you may find that you want to declare constant values inside the type body and expose them through a static function. So let's go ahead and search up the object type methods in Live SQL. So go to the home page, object type methods. And we'll be exploring lots and lots of this in the next several minutes, but here I have my food type. I've created a member function. We'll come back to member functions in a moment. Let's go find the static function. Statics are less common to be used, but they can happen. So here's my static function. I've got my 3 attributes, my static function. Here's my version. And then I can simply call it. And again, since it's a method, in this case, it's the type dot the method. And it's the only type of method in which you use the type instead of the instance. Come back to that. All right, so those are static functions. Let's take a look at member methods, which is really where you see most of your activity for object type development. So with a member method, it's also defined in the object type, but it's attached to an instance of the type, not the type itself. So you would create a member method to operate on the values in the current instance of that type and either return values, or it could be a procedure and you simply make changes based on it. Now, this is where you can add new ones to subtypes. So I can have member functions at the type level. I can then create other member functions at the subtype level. I can override them and so on. So let's take a look at some of these things now in Live SQL. So back up to the top. And again, just to drive this point home, you can go to Live SQL. You can look up individual scripts. You can run the scripts, play around with the results, change the code, not in my script, but you'll have your own copy of the script and you can make your changes to it and just have fun exploring. Okay, so a very common aspect inside an object-oriented language is that for any type, you have a string representation of an instance of that type or a member of the class. And that's not something that's built into object types by default, but I can create that. So I have a member function called toString, convert my type to a string. And then inside my object type body, I implement my string, my toString function. And what I'm doing here, notice, is referencing self dot. Self is a keyword that indicates it's the current instance of the type. I don't have to qualify with self dot. I could just reference the name of the attributes, but it's better to do it explicitly, then you don't have any confusion and it's easier for people to read and understand your code. So I create my type body with my function. Here's a call, a declaration of a variable or an instance of this type. I call the constructor function. We'll come back to constructor functions when we talk about user-defined construction methods. I pass it the values for each of the attributes. And notice I need one for every one of the attributes. And then I can call the toString method to return the string version and display it. And there it is. Okay. Now, by default, with a member method, there is a self parameter. You saw it referenced right here. And it's default, so you don't have to include it. But a pretty common good practice is to include self in the type. And that's being very explicit about the fact that this function is operating on that self instance. Don't forget, you can put questions in the Q&A, and at some point, I'll notice them. And notice when you say, Stephen, I can't see what you're showing us, but hopefully we're good from here. Okay, so those are member methods. Let's talk about user-defined constructors. So again, one of the really nice things about the object model is that every type, every class, comes with a constructor function that you can use to create an instance of that type. And as you saw here, it is by default available. So I didn't have to create food OT. Since I created a type, it had its own constructor. And these constructors are also available for nested tables and V-arrays, also part of the object relational model. And as of 12C, you have qualified expressions so that you can, for nested tables, for associative arrays and for records, you can also, I think that was 18C. You can also then call functions, that we call them qualified expressions, not constructors, for whatever reason, for an associative array and even your user-defined records, and it'll return an instance or a variable of those types. But they first appeared in terms of constructors with nested tables and V-arrays and object types. So there it is, there's my constructor function. Now, the problem with the constructor function is that it's not very flexible. Let's suppose I have a type with 15 different attributes. I track all sorts of stuff, and they're all publicly available in the package spec, in the type spec. So everybody knows they're there, but still, when I want to create a new instance of that type, I have to pass 15, 16, 20 values. And often I will sit there typing null dot null dot null dot null because they're not going to be set when I initially construct my type. So a very common thing that people will do is create user-defined constructors. Let's see if I've got one of those. There we go, user-defined constructors. So let's take a look. So there's my default constructor. I've got to pass in all those values. And notice right in line, I can call the constructor. I can pass the values. This returns an instance of the type. I can use dot notation and then use one of the attributes to show the name, peanut. But you know what? I really don't want to have to pass all that stuff in. In fact, a lot of times I just want to create it without providing any values. Okay? So I add constructor function food t, return self as result. Right? So it's got to act like a constructor. It's got to be declared that way. It's got to return an instance of the type. But notice now, I don't pass any parameters at all. And inside my function, now I do need a type body. Inside my function, I can set the name or whatever values I want, and I don't return self, I simply return control, and that returns the instance back and assigns it to the variable. And here's an example of adding that self parameter as well, but notice in the case of a constructor, it's in-out because I'm changing it. So it's not uncommon to have multiple constructors. You might have 2 or 3 or 4 for different combinations of data that you want to provide. You can even pass in values that are not parameters. There's no limitation on what you're doing in that parameter list. But as long as you declare it as constructor, as long as you return self as a result, you'll be able to provide an alternative to yourself and to your other users of your type. Okay, and the last and probably most interesting type of method are the map and order methods. So I've created a type, and I maybe even have put that type inside an Oracle relational database table. And then what I want to do is manipulate those types. For example, I might want to order by the type. I might want to compare two instances of the type. Is this one greater than or equal to that one? Are they equal? Is there a concept of equality? And by default, you don't get that behavior out of the box. What you need to do is create methods that will do it for you. Let's take a look. Back up to the top. Map and order. All righty, let's take a look. So in this time, I'm going to create a type, food t. Let's make it a little bit bigger. And then I'm going to create a table. And that table has in it a column of type food OT. So now you're getting to the real object relational model. You're actually blending different aspects together. I can also have a table of object types, not just as a column. And then I'm going to populate the table. So notice right inside my insert, I call my constructor. Since it's not a user-defined constructor, I have to pass a value for every attribute. And off I go. Okay. And now let's take a look at, there we go. So now what I want to do, notice that in statement 4, I do an order by. So I'm doing an ordering with my table that has these object types in it, but I'm looking for a specific name. So this is ordering by a string. No problem. It's a varchar2. Because of our nice, powerful SQL syntax and integration with the object types, I can dive right in there, reference the name, and order by it. Cool. But if I want to do an order by or a comparison on the object type instances themselves, not an individual element, I can't do it. So I get the 22950 error, cannot order objects without map or order method. Okay, so what do you do about that? And notice, it's not just in SQL, it's in PL SQL as well. So check for equality, not possible. Inequality, not possible. All right. And you've got issues with lobs as well. Let's now start again. Now I'm going to create a food type, food OT, and it's got a map, and we're actually going to look at the order. But you know what, before I do this, let's go back to PowerPoint, because I want to talk a little bit about the specifics for each one. So the map method is pretty much the simpler of the two. And what it does is perform a calculation on a single instance of the type. So notice inside the map member function, I'll reference self, and that's all I can reference. And I can basically say, for example, in the case of my food, that I'm going to order by protein being the most important, liquid second, as if that's a food group, carbohydrate, vegetable. So notice I simply return a numeric value that I can then use for sorting. Go back to Live SQL. Here's my map member function. It operates just on that instance, that member, returns a value. And then I'm going to insert a bunch of data. There are my constructors. And now I can order by main course. Now, looking at this, yes, it's not alphabetical order. I was thinking that would be annoying, but it's not alphabetical order. Stir comes after shrimp. So what it's doing is looking at which ones are protein and ascending, right, ascending. So I was thinking, wait a minute, but I thought protein had the biggest value, so wouldn't they come first? Well, no, they come last because it's ascending. So all the protein elements are at the bottom. So there's the ordering by using the map method. Okay, so why would you have an order method? Well, the order method works quite differently. The order method returns one of three values: a negative number, 0, or positive. You can return any values you want according to that criteria. I generally use 0, 1, and -1. And in this case, the order member accepts as a parameter another one of the instances. So what you're doing is then comparing the self instance of the type to the one that's passed in to ask, is it less than, equal, or greater than, negative, 0, or positive? And generally speaking, you're going to use this type of member function, order instead of map, if your algorithm is much more complex and you can't do it all in a single map method, which again, doesn't reference anything outside of that self. So take a look. Alrighty, so now I'm going to add an order member function. I'm passing in some other piece of food of that type, and I return an integer. And I've also have a little type hierarchy here. Alrighty, and I have a type hierarchy because what the function is going to do depends on the type of food it is. So the rule is subtypes are always less. If it's a food, it's always higher than, greater than dessert, which is always greater than cake. But if it's of the same type, then we apply rules based on, well, you know, whatever your rules are. So just to not to get too caught up in all the details of this, first of all, what I've done is create different constants so that helps me understand the code I'm writing. So 0 means equal, 1 means greater than, and -1 means of greater than, so the other food coming in is greater than the self. And then essentially I go through the logic I just said. Now, just to look at a little bit more of the object type pieces here. Remember I said that if it's food, it's always greater than dessert, greater than cake. Well, how do I know what type it is? And in that case, I can use the is of syntax. I can say if self is of food type. And if I say only, then it has to be an exact match on that type. Otherwise, a dessert is of type food, and so on. But here I'm very specific. If it's only food, then we're at the top. Then I'm going to return equal. I'm sorry. If it's food explicitly, then if the other food is only food as well, then they're equal. Otherwise, it's greater than. Then I go to dessert, then I go to cake. Now, if they are equal, so they're both food, so they're in the same ballpark, then I do my further analysis, then I look at the different food groups and do comparisons, etc. Obviously, the specific syntax or the specific logic here doesn't matter. What's important is that you can do this kind of complex logic in an order method, an order member method, that you might not be able to do in a map member method. The result, however, is pretty much the same. If I take a look at the kind of code I can run then, I can do order bys. I can do where clauses with comparisons, both in SQL and in PL SQL. All right. There you have it, folks. So let's go back up to the top real quick. So when it comes to working with object type methods, you've got a lot to choose from. You can use static methods, and those would be used for things like version numbers, static constants, things that apply to any instance of the type, regardless of what values that type, that instance has. Then you've got member methods, which is going to be the most common one, in which you're simply applying rules for individual instances of the type. So they always operate on that self of the type. User-defined constructors are methods that come in really handy when you don't want to have to go through passing a value for every single attribute in the type, and maybe even apply some of the logic. For example, I always want to uppercase the names, so you could apply upper directly inside that constructor function. Be aware, however, that there's no way to turn off access to the system-defined constructor. So if you have a rule like it must be uppercased, then you're going to have to put in some extra logic somewhere. For example, table, in a row in a table, you can have a trigger that then applies the upper logic, but you can't really mess with the system-defined constructor. And finally, map and order by methods. When it's time to do some comparisons and ordering of object type instances, whether it's in a table or in PL SQL, you'll need those to make it all happen. All right, well, that's the end of my presentation. Short and quite sweet, I hope. I had almost no questions, so let's take a look and see if anything comes in now. So I just had a question. How can affect this types the export import between databases? So do I have to be concerned about exporting and importing from a database will include object types or not? Absolutely, they will include object types. First of all, it's part of your code base. So just as you'd export packages and procedures, you'd export object types. And in terms of the data itself, if it's inside a table, in a column in a table or even a row in a table, it's part of your table. It definitely gets exported. So no problems there. Other questions? How does indexing work when a table column is an object type? Chris, are you on the call? I just realized that I haven't worked with object types and tables in a long time. And Chris Saxon is not on the call. Bad boy. So I'm not exactly sure. I'm pretty sure you can index elements in an object type, but I don't have an answer for you immediately. But we have lots of people on the call. So let's find out if we have anybody who'd like to answer that. Anybody out there with experience with using object types and tables and doing indexing? If not, I will post an answer to that on my Twitter account. So don't forget to follow me. And in case you don't know it, I'll put it in chat. My Twitter is SF on PL SQL. The question, how about the performance of using a function in a type? Well, you're going to see this. There are no new issues or any different issues for performance overhead of calling methods inside types compared to, say, subprograms in packages. And basically, you'll see the same dynamic that you'd have with regular old PL SQL functions and procedures, in that there will be a context switch if you use them from within SQL. So when you call an object type method inside a SQL statement, the PL SQL runtime engine will kick in, and you'll do a context switch. And by the way, Chris Saxon was not on the call, but Roger Ford's on the call, product manager for Oracle Text. And he tells me that you should be able to use a functional index, so a function-based index with those methods to do the indexing. Okay. Well, I kind of figured there might not be too many questions on this one because I don't think a lot of people use object types, but it's good to know about the different types, especially, again, if you start using other object types already defined in the database, even if you're not building your own. But then, of course, you don't get to choose to build member functions and user-defined constructors and all that kind of fun stuff. Oh, here we go. Question from Nils. What method would you prefer for a two-string method in a hierarchy? Repeat the code in every type in the hierarchy, or add another method, getData, which returns the pure data and which is overwritten in each level of the hierarchy, and include a call to the getData, the parent type, and only add its own additional attributes? Cool. So that's an interesting question that brings into mind another feature of Oracle object types that was added in 11G, which is a generalized invocation. Let's go back to Live SQL. And let's look up supertype. I think that'll do it. Not supertype. Okay. In fact, I think this pretty much is exactly what you're asking about, Nils, in terms of the example. So I've got a type called food, and I've got a member function toString that returns varchar2, and I construct my string. So let's take a look at some other examples of methods that involve overriding, which I hadn't touched on before. It's part of the object type hierarchy. So now in dessert is under food, so I simply add one attribute to it in addition to the others. And then I say, I want my own toString function, my own toString method for dessert, not just call the food method. So I'm going to say overriding member. So now my member function is explicitly designed to override the type of the supertype, the method of the supertype. And of course, the parameter signature has to match exactly for that to work. Now, here what I'm doing is saying, okay, so I'm going to call my dessert function when I want to see toString, and it'll display dessert, etc. And then, but what I don't want to do is hard code or repeat the logic from the supertype. In other words, I want to add on to it. So as of 11G, you can say self as and what the type is, and can it be any supertype above it. So food, dessert, cake. From cake, I could say self as dessert. I could say self as food. And what this will do is go up the hierarchy, pull out the method for that hierarchy, and then invoke it, and you can use it as you wish. And I would say that this is the best way to do it. Instead of repeating text, I could, for example, simply say that I want to take all of this and add it to this. Instead of here, I would add in the other concatenations. But then I'm having redundant code. So what you do is use the generalized invocation that allows you to add on from the supertype without losing all of that. And here's a second override. So now I'm overriding desserts method with my own cake method. And notice now I'm saying self as dessert. Now self as dessert will call this method, which in turn will call the food toString method. So it'll actually cascade all the way up. So that, I think, is the best way to handle those kinds of situations. And let's see, anything else here? Yes, let's take a look at dynamic polymorphism, which I also referenced in there. So you've probably heard of the word polymorphism before. It means multiple shapes. There are two types of polymorphism. One is static and one is dynamic. Static polymorphism is something you should be really familiar with. It's also known as overloading. So with overloading, At compile time, the compiler determines which of my different procedures or functions that have the same name but a different signature match the invocation. So I match them up at compile time, and then at runtime, it just executes the choice made at compile time. That's what the static means in static polymorphism. But dynamic polymorphism is different. Dynamic means at runtime. So with object type instances, at runtime, the PL SQL engine is going to decide which of the methods in the hierarchy and the overridings is the best fit. So let's take a look here. I declare my contents of my refrigerator based on my foodstuffs nested table, which is a table of foods. So it's a list of foods, and I'm going to stick stuff in my refrigerator. I'm going to declare a food type, Eggs Benedict. I'm going to declare a dessert type, a dessert instance, strawberries and cream, and a cake. So one of each of these three. Now remember that this works. I don't see an error. This works because even though it's a table of food T, because of substitutability, every dessert is a food. Every cake is a dessert, is a food. So they all fit into the food type or the food array. Now, when I call them, though, you get something very interesting going on. So toString, this thing is a food type. It's a table of food T. So when I call toString, you might think to yourself, well, it's going to call the food toString. It's not going to call any of the lower or sub methods, the overriding methods, but that's not the case. So as you can see, it found the right method. It found the appropriate method for each one based on its type. So even though these were put in a container, a list of food types, it remembers, the PL SQL runtime engine remembers that these are actually desserts and cakes, and it calls the right method. So that's an example of dynamic polymorphism. Now let's take a look at skipping over dessert. So now I'm going to change cake's method. So I'm going to show cake, but then I'm going to say self as food. Forget about the dessert toString. I don't care about that. And now when I do the same thing as before, notice that cake goes right to food instead of cake, dessert, food. So you have a lot of control with these generalized invocations as to how far up or which part of the chain of subtypes you want to go through. Nils, I hope that answers your question. And Rajendra, there are some more examples of using methods. Let's see if I've got anything else. Yes. So Judith tells us that you cannot create an index on an object type column, but you can use an object attribute in an index. For indexing object type columns, you can probably create your own domain index type, which is what Roger Ford alluded to as well. Thank you, Judith. And Patricio says, I use a lot of object types in my PL SQL programs. However, when persisting to the database, I sometimes use object type columns, and sometimes I use programs that take attributes and insert them as standard type columns. I'm having a hard time deciding when to use object types or this translation. So the point he's making here, let's see, do I have an example? Let's see. Let's bring up the map and order example since I believe I created tables, yes. So in this case, I've created a table, and it has as a column food OT. And the question that Patricio is asking is, well, should I store the main course like this, or should I store name, food group, grown, and should I expand it out? So I'd say that the decision about which way to go probably depends in part, at least, on how stable you think your object type is. So no question, if you put your type as a column in the table, you're making things more complex. Our SQL extensions for the object type interface handle it, so you can, as I showed here, you can get down into the type dot attribute name and get the values. And there are a number of features that are added to help you deal with these different types, especially in the context of substitutability. Sometimes your subtype attributes are not automatically visible, so you can use treat in your SQL statements to then treat a type as a subtype and get the columns. I think I probably have an example I can show you of that. But the bottom line is that your SQL will be more complex at a minimum. If you expand them out, if you say, well, I'm going to have in my relational table, served on, name, food group, grown in, then you don't have any of those complexities. You're back to the standard relational model. The downside of that will be that if you add an attribute to the type, you have to go and add a column to the table. You have to keep them in sync. And of course, you have to do the merge and the divergence of the data if you're moving it between object types and your relational model. So I don't think there's an easy answer one way or the other. But I think, and you probably have some overhead in performance in your SQL engine compared to just having relational columns, though I expect it will not be too much of a difference. So Patricio, I hope that helps you. You want to keep it simple, and you think your object types are going to be pretty stable, I would decompose them into columns. But it shouldn't be that much trouble to keep them as a column in the table as an object type. Other questions or comments? Okay. So that covers my methods for object types presentation. Thanks for the good questions, and thank you, Judith and Roger, for answering some questions for me. So I've got 2 people raise their hands, but I think that was from before. Yes, that was from before. So thanks for joining me, and we'll be coming back in a month to take a look at some Oracle PL/SQL 20 new features, and Chris Saxon will be showing that. And then the month after, so let's see, it's July, August, September, we'll have a presentation from one of our product managers on using PL/SQL to build APIs to manage your Oracle Cloud Infrastructure services. That should be very interesting. And if you're doing anything with the Oracle Cloud right now, you'll definitely not want to miss that presentation. And we'll go on from there. So thanks for joining me. Hope you are staying safe, staying masked, keeping you and your family healthy in these extremely troubling times. And but we can take solace and some and hide away in our world of coding and let the craziness of the world pass us by, at least for small amounts of time. So go with that, and have a good summer, and hopefully I'll see you next month. Take care, everybody. Happy coding.